All right, gang. So this is the intro to JavaScript. We originally planned to be joined by Franklin Caval. He won't be joining us for this talk today, but he is a mentor, so please feel free to ping him. He's an absolute pro at like web dev stuff in particular, so please feel free to ping him with questions as well. I'm also a mentor here, so please feel free to even, we'll have some time to do some Q&A. But otherwise, just feel free to ask questions. So this is our intro to JavaScript. So what I want to go through today is I want to be able to introduce the language and a tiny bit of the history, not anything too complex, but just enough to get a little bit of context. I want to be able to introduce the ecosystem. I think that JavaScript in the past 5-10 years has really grown to be kind of a different beast than what you might originally anticipate. And I think that it's important to introduce the ecosystem. And then we'll introduce some of the more complex language features that hopefully might be able to help you develop your applications through the hackathon. So JavaScript was released in 1995. It was intentionally coded to have a syntax very similar to C. So semicolons, braces, lots of very similar stuff. JavaScript initially had staged releases. So every few years you would see a release. So the first like major release was like ES3, that was very popular. ES5 came around a few years later. Don't ask me why ES4 was missing. There's a long history there. But finally ES6 was released in 2015. Since then, we've moved away from multi-year releases, and instead we do a yearly annual release. So ES6 has gone away in favor of ES 2016, and then there was ES 2017, 18, 20, so on and so forth. JavaScript is also known as ECMAScript. There's some long, complicated history that involves Oracle, and it involves Mozilla and Netscape browser. And long story short, if you ever hear the word ECMAScript, ECMA script, it is referring to JavaScript in particular. So they are the same languages, just a different name for the language for historical reasons. So a super simple example of JavaScript might look something like this. You can see that we have a class. That class has a method where that method calls math.random. Math is a built-in class in JavaScript. So math.random returns a number between 0 and 1, so like a float, so 0.1235, so on and so forth. Here we have a string. Let declares a variable that you can reassign. Const is a variable that you can't reassign. So for each item in an array of items, run the method and add it to the string and then console log that string, right? So pretty straightforward example. You can see that we have for loops, we have classes, we have built-in functions like the math.random, but we also have features like asynchronous support in our code, which we'll touch on later. We have functional code, which again, we'll touch on later. And there's so much more to JavaScript. Like any other language, JavaScript has evolved to be a very cohesive, complex language that can stand against other languages. It's not just for scripting. It's not just kind of a toy language. It is used in production in huge companies. So that said, let's take a look at the ecosystem, right? So the most popular item in the ecosystem is the browser, right? So you can build websites using URLs. You don't have to install the application, which is super advantageous if you're trying to avoid that. There's JavaScript for user interaction. There's HTML for content layout, and there's CSS for styling. So HTML might define the shape of, or like the button's contents. CSS defines the shape, the roundedness and the blue of the button, and then JavaScript may make the button clickable and the user interaction within that click. And most people think that's the end, right? That's the only time that you can use JavaScript, go home. And that used to be the case in the 90s. It's no longer the case currently. So there's a lot that you can do with JavaScript. One really predominant way of using JavaScript is using Node.js. This is a way of using JavaScript without a browser. So you don't need HTML, you don't need CSS, neither of those languages apply here. But you are able to call native code. So let's say that you want to read a file from your file system. You can call C code that will read your file system, and it will return the data to JavaScript. Now, you don't have to know C to call native code. There are some libraries and let you call native code much easier without having to know C or C++, something along those lines. So Node.js is super useful for both building servers. Node.js powers a ton of the most powerful servers that are used in production today, but you're also able to build desktop applications. And we'll touch on that a little bit more, both of those a little bit more in the future. But Node.js being able to run on the desktop without a browser opens up a whole world of an ecosystem on its own. Part of that ecosystem is using NPM. So if you've used NuGet for C# or you've used like Ruby or pip for Python, something along those lines, you may be familiar with the concept of packages or libraries. So the concept of a library is being able to take code that other people have used and use it in your code base. So for example, Chalk allows you to change the color of text in your terminal from your Node application. It's simple to install commands, so simply do npm I whatever. You can easily upgrade your projects. Usually you follow like a semantic versioning, so you make sure that the major version is the same. But the idea is that if you want to be able to use Chalk, you run npm install Chalk. npm comes with Node, and then you can just use Chalk in your code base now. Now we're going to talk about bundlers. So we talked about building websites, and websites are particular because browsers have never really, there are ways to import other code, but they haven't been standardized for very long, and their support isn't perfect. So what you can do is you can take multiple different files, so like a .cjs file or a Sass file if you've used Sass, and you can compile them from multiple different files down to a small selection of files that your browser does support. So if you ever use React, like JSX files need to be compiled down somehow to JS files. And the most popular of a bundler is called Webpack. There's also Parcel and some others. But basically, they just combine multiple files on your development system into a small selection of files that are easier to read from the browser, easier to deploy. And in some cases, it's the only way to use those libraries for your browser application. There's also Transpiler. So you can see that it compiles JavaScript, which is on the left side, to JavaScript, which is on the right side, which seems a little confusing, right? Like, why would you compile from one language to the same language? The actual reason is that old browsers, so like Internet Explorer or even older versions of Safari, or even there are features that are so new in JavaScript that are supported in Node that are not yet supported in Chrome. You can compile from a new version of JavaScript to an older version of JavaScript that is supported in those older browsers that you can then send to your website. Usually you combine a transpiler with a bundler. So you'll have code in your bundler that will then be transpiled and compiled down to smaller files. So Babel is part of a pipeline that allows you to compile your JavaScript to older JavaScript. There's also Typescript, which adds typings to JavaScript. So if you're familiar with languages like C, or probably closer to C++, or other languages, you might be familiar with like object shapes. So being able to define that this object of hello message should have two keys, to and from, and both of them should be a string. So if I went into my TypeScript application and I said const hello message, and I tried to make one of these a number, my compiler would yell at me and tell me, hey, that's not a string, that's a number, don't do that. So we have very simple types, which is up here. We also have more complex types, which is here. So TypeScript introduces a compiler step. So Babel was a transpiler step. TypeScript is a compiler step because you're actually going from one language, TypeScript, to another language, JavaScript. That said, all TypeScript or all valid JavaScript is valid TypeScript because TypeScript is an extension. What are the advantages of using TypeScript versus JavaScript? So TypeScript enables you to catch errors much earlier than you might otherwise. So let's take something like this, right? Let's say that I wanted to do const, or we'll do a function. Function get number. We're going to pass in an object. we're going to return object.number, right? So if I do get number and I pass in an object with a num, it'll return 12, right? But let's say that I don't have this key and I have other. I'll get undefined. So there are ways to tell TypeScript to disallow you to do this, and it will actually, like at the compilation step, it will stop you from making mistakes like this. And it may be even as simple as you forget that it was called num, and you try typing in number, and you're trying to debug why undefined isn't working, right? Like, why isn't this returning what I'm looking for? And, you know, so TypeScript can help enforce you to do kind of the correct way of coding without causing so many errors. So the main advantage of TypeScript is the developer tooling aspect. The other part of TypeScript is that it usually integrates with Babel. So when you call TypeScript, TypeScript has had some features in JavaScript that have not been standardized yet. So it can compile from like super new like test versions of JavaScript to JavaScript, which is nice. But yeah, when you do the compilation, it removes the typings. So while you would get an error for what I showed during compilation, you would not get that error during runtime. So if you actually run your application, you won't get the compiler errors. You only get the errors during compilation. So that's something to keep in mind. So going on in the ecosystem, there's also React and there's alternatives. Two of the biggest alternatives to React are Angular and Vue. Personally, I think Vue has the best docs, but React is definitely the most popular and most widely used in the job market right now. The idea behind all three of these frameworks are very similar. What they do is they break your application into different components. So here you can see an example of an app that's been broken down. You have your app, which contains everything. You might have a header component. You might have a comment list component. That comment list component might have comment components that you can reuse more than once, right? So you can see there are two comments here, so there would be two components. You can see the comment form might have its own logic. And the nice part about this is that because you're breaking your app into smaller parts, you can reuse those parts. So just like you can reuse a function multiple times throughout your code base, you can reuse components. So for example, comment can be reused multiple times, and you can store complex styling, complex UI logic. So like if you click a button, it might do some complex math operations. And React and these alternatives allow you to build really, really complex web applications much easier to manage and go forward with. They're used by huge, huge companies. I used to work for Hilton, and we wrote React to power our entire website. And our website had millions of users every week. I remember we launched a new product at Hilton that was basically like group booking hotel rooms, and we had made something like $8 million in the first 2 or 3 weeks. Like absurd amounts of money, absurd amounts of traffic, and React and these alternatives are able to handle that size and scope of traffic and complexity. There's also React Native. So this is my app in particular, GetShark. What you're able to do is you're able to reuse some code from React Native and React. So you can kind of build websites and mobile apps at the same time. But mostly React Native allows you to build iOS and Android applications and share the code base between the two. You can reuse most of your React knowledge. So like if you have a really good understanding of CSS and React, you can build native apps pretty quickly using React Native. And the really cool part about React Native that a normal React app doesn't have is that you can call native code. So for example, just like Node introduces the ability to read files from your desktop, React Native allows you to read files from your phone, to take pictures, to do all sorts of things. I think you can take pictures on websites, but there's a lot of things you can do with native code that is not possible with just a web application. So React Native kind of helps you bridge the gap between the requirements for native code and web code. So very cool. There's also Electron. So if you want to build desktop applications, we touched on that when talking about Node.js. Electron allows you to use HTML, CSS, and JavaScript to build desktop applications. So being able to use Node to call native code when needed, but otherwise use web tech to be able to build out the UI and the logic is super cool. You can use React, or you can choose not to use React. You can use Angular. You don't have to use Angular, so on and so forth. And one of the most popular applications that uses Electron is VS Code. Slack also uses Electron. I believe Discord uses Electron. A lot of huge applications that are in production use Electron. And it allows you to share a lot of your code base between different teams. So going into servers, there are two types of servers I want to talk today about. The first server is called a REST server. So you can see that each one of these routes has like a put, post, get, delete, update. There's some other commands. But the idea is that if you run that command against this URL on your server, it will do specific actions. So this post update uploads an image. You can add a new pet to the store. Swaggerio is just a way to document REST servers, but REST servers don't inherently generate documentation. You have to add support and document it yourself. But you can build REST servers easily using Node. Express.js is a library that's very, very, very common for building REST servers. And you can use any database you want with REST. It doesn't really care what database you're using behind the scenes. You could even just use normal files, as poorly scaling that would be, but you can do it. The other type of server that's really quickly gaining popularity is called a GraphQL server. So this page is actually usually generated with GraphQL. It allows you to explore your types, your endpoints, which looks more like a JSON schema than like just endpoints. This JSON schema is type strict. So if you try to ask for a property that the server doesn't have, it will actually tell you that it doesn't have that property before running. It'll throw an error. Because it is type strict, you can generate TypeScript files. So you know exactly what your endpoints are going to return without even having to go call your endpoint. Apollo Server is the most popular library for building these. Again, you use Node to be able to build a GraphQL server. You don't have to use Node. You can use other languages for each of these servers, but you're able to use Node for these, which is more the point. The other really cool part is that GraphQL servers are able to self-document. So if you added comments to all files, edges, Node, whatever, you can click this button and it'll actually give you the documentation that is in your code that explains what each one of these does. So GraphQL is really quickly gaining popularity. Most servers use REST just because they've been kind of the industry standard for a long, long time. GraphQL is being more utilized. When I was at Hilton, we used GraphQL servers in particular because it's so convenient to scale upon. So now that we've gone through some of the ecosystem, let's talk about the language itself. We'll start with something that we've already kind of had an early look at, classes. So if you're familiar with Java or C++ or any other language that has classes, this is going to seem pretty familiar to you. We have a base class, vehicle. We have properties, type and speed. Type is not default defined. Speed is default defined to 0. The constructor sets type to the item that's passed into the constructor. And then we have methods such as set speed. Val is able to update the speed property. You'll notice that we're using the this keyword. The this keyword is kind of complicated in JavaScript. We won't be touching on it too much today, but please feel free to message me if you're curious more about the this keyword, if you've seen it outside of classes. I will be happy to send you articles that explains a bit more about it. But yeah, so you can take the vehicle, you can say new vehicle car, and you can see that type is now car and that speed is still 0. And if we were to call const car equals new vehicle car, so on and so forth, we could set the speed as well. We can also have extended classes. So car extends vehicle. We have miles in a car. The super keyword is what calls the original constructor. So here you can think of this as the constructor for the vehicle class. And we're passing in car. So it was a type car with speed 0 with miles 100,000. So that's one way you can do class extension. The one thing that JavaScript does not have is abstract classes. That's because JavaScript does not have the concept of types, so it can't really implement abstract classes in a meaningful way. That said, we touched on Typescript earlier, which does have the concept of types. So you're able to use Typescript to generate abstract classes, and abstract classes can be used very similarly to other things. So if you are using Typescript, this bottom bullet point does not apply. There's also the event loop. The event loop is very interesting. So JavaScript is known as a single-threaded asynchronous programming language. What that means is that all of your code in JavaScript, all of it, is ran using one thread. So there's no concept of multi-threading using JavaScript. There's an asterisk next to that statement, but we won't get into that asterisk. So all your code is single-threaded, meaning that if you try to run multiple things at one time, what's really happening is that it's really rapidly switching context back and forth between the two things you're trying to run. And because it is on a single thread, you can actually block that thread. So let's take a look at like an example of what the event thread might look like. So here we're basically saying on the button click, so this button, run goodbye after a second, run hello sooner. So you can see when I click this, oops, when I hit save and run, it's listening for the button click. So it'll run the on click, it'll set the timeout, it'll set hello, the callback will finish running, and then it will say goodbye, right? But if I click this multiple times, you can say that it goes through every operation individually, and it does not continue multiple things at once. So it's only doing one of these things at a time. So it's kind of putting a pause to run through each of these things. And then once it's done, it'll actually call hello. So again, single threaded. What I meant by being able to block that is that, let's say, actually, this is, I don't want to run this on this page. Hang on, my computer is being a bit weird. There we go. So let's say that I have a timer, right? So let's do set interval. We'll do val, or here, window dot time equals 0. And now we can say set interval console.log window.time plus equals 1. So what we're saying is for every second, add 1 to window.time and console log it every second. So you can see 2, 1, I don't know why I started with 2, but 2, 3, 4, 5, 6, right? So if I do alert and I say hello, alert is known as a blocking function. So you can see that it ran the hello alert right there. But notice that the timer isn't counting anymore, right? So we could sit here and we could wait all day and that timer will never increment because it's not running anymore. That timer is not executing because the event thread has been blocked. It is waiting for alert to return code. And because of that, the rest of this code can't execute, right? So if I hit OK, now it will continue to type. But like console.log is not blocking. So I could do console.log hello, and it'll run in the background and it'll continue to execute everything else. So you have to be a bit careful about how you engineer your code so that you are not blocking the event loop, because even on this page, let's go back to the example I was using. If I type in alert, you'll notice that I can't click on any buttons anymore, right? And you may think that's because the browser is preventing me because it's showing a dialog, but that's not the case. What's happening is that all JavaScript and all interactions with the user are completely blocked because they rely on JavaScript. So each one of these buttons no longer functions at all because the UI is being rendered in the same thread as the event and all the logic. So now I can't click on this anymore. But if I click OK, now I can click on it. So that is the event loop. Also, I will mention that while I took a weird detour on the whole event loop, please go watch this talk in the bit.ly. I did not write it, but it is a talk that like completely changed the way that I thought about JavaScript and how I wrote code with JavaScript. So please, please, please go check out that bit.ly because it's hugely important of a talk. So we also need to cover a concept that may be familiar to some, especially those who may understand what lambda calculus is. But first, we're going to talk about functions as values because we're going to talk about how JavaScript is kind of unique with how it handles things. So if we take this code, right, this callback function, right, we do function, call this function, callback, turn callback, hello world. Right? What's happening here is that this callback, we are expecting to pass in a function because functions are just values. You can pass functions as properties. You can use them as values. Like you can pass them just like you could a number, right? So if I run call this function and I pass in the number 2, it'll throw an error because the number 2 is not a function, right? But console.log is a function, right? So it's implemented using native code, but log is a function. So if we do call this function with console.log, you can see that it calls hello world because we're passing console.log into callback, and now we're saying return console.log hello world, right? So you can pass functions as properties, but you can also pass functions as values. So here we have a function that has a return statement. So let's type that up really quickly. We are returning a function. Function is returning hello world. So if I type in return this function or return another function, you'll see that it gives me a function as a return, right? So if I call that function again, it will give me the string. So you'll notice that I have 2 set of parentheses here. The first set of parentheses calls the first function. The second set of parentheses calls the second function. So I can do const hello world function, equals return another function. And now hello world function is also a function that I can call, right? So you can use functions kind of as like any value. You can pass it, you can store it in a variable, you can do kind of anything you want with it, right? So JavaScript utilizes this to get around its asynchronicity issues, right? So the idea that you can call code and wait for a result using a callback is super useful in JavaScript and has been kind of standard place in the JavaScript ecosystem for a long time. So for example, we have this for each function. It takes an array and it takes a callback function. So for each item in the array, so get the index for each item in the array, run the callback function and pass that item in the array. So here we're doing for each cars, pass in the function here, and we're console logging the first parameter. We're ignoring the second and the third parameter, so you can ignore those 2. But here, we pass in the function. The first item in Ford gets called through the callback. It gets passed, so we're console.logging Ford. We continue through the Ford loop. We get Volvo. We pass that to the callback, console.log Volvo, so on and so forth, right? So you can use it to abstract logic. You can tell when something is done. So something like this. So FS is built into Node. So if you run read file, you need to it takes a few milliseconds to read that file, especially depending on the size, right? So if the file size is really large, it might be a few seconds to wait to be able to get the result. And once that result is done, you can call this callback with error if something went wrong, or data if nothing went wrong. So this is how you wait for something to be done. You can even stack your logic, right? So here we're checking if stat basically says, does this file exist? So does message.txt exist? If there's an error, it means that it doesn't exist. So go ahead and return. We don't want to do anything else. fs.read file, if it does exist. Once we read the file, we want to see if the data includes hello. If it does, we want to say goodbye. So we'll append the file. We'll check and goodbye. We'll make sure that that ran properly. And if it did, we'll say this is done now, right? So you can stack callbacks on top of each other to be able to get more and more complex code. But you'll notice something. Lines 8 through 11 aren't really code. They're kind of just closing off these callbacks, right? So what we end up calling this is callback hell, or a callback Christmas tree. So you can see that there are like lines 15 through 26 are all just like, right? Like a Christmas tree and like, you know, Hadouken or whatever. So this is a kind of, I forget the word, but a contrived example, that's a word. But this does actually happen in real code bases very frequently with older versions of Node. Newer versions of Node support something called promises. Promises can help be an alternative to the callback pattern, although it doesn't replace it one-to-one. It's just useful as an alternative. It allows you to do async processing. So what we're saying here is return a new promise in this function, and after a random number of times within a second, go ahead and resolve it, right? So here you can do a chaining. So .then is returned by promise. So actually, let's take a look. So the most basic version of a promise is promise.resolve, right? And if I do .then, I can console.log, I am finished, right? So you see that that callback was executed immediately. But if we did something like the get random time, we can do get random time promise .then console.log. Done. You can see that it takes a second before it runs done, right? So you can chain these thens together. So let's say that we wanted to make it wait even longer. We could do, okay, that's not what I wanted. We could do get the random time, then we could chain this however many times we want. And now you can see that it's taking 1, 2, 3, it's running after each one. And then done is called finally at the end, right? So thens chain together. This is called a then chain. And you can also do a catch anywhere in. So you can see catch here. So you use reject as the second item in the promise. So let's say that if the number is less than 400, we want to throw an error and say the number was too low. And what we can do here is that we can kind of like throw the dice and check whether that's an error every time in the then. And if any one of these three throws an error, .catch will come into play. So it's very helpful for catching kind of arbitrary errors in a broad catch statement. So we can rewrite our code here, our FS code, to something that's a little more flat. So you notice that the bottom example is using promises. We get rid of the kind of like downward sloping thing here. And we're saying fs.promises is just an alternative to the callback pattern here built into Node. We're doing stat message.text to see if it exists. The error will be caught later if there is one. Then read the file, right? Then take the data from the read file and see if it includes hello. If it doesn't, go ahead and return and just not do anything. If we have the hello in there, we're going to append the file saying and goodbye. And then finally, we're going to console log this is done, right? So this is a kind of small contrived example, but you can see that even in this small example, that instead of our code looking like an arrow, it's much more flat, which can be much easier to read, especially in larger applications. But that's not all. Not only is there .thens, there's also async and await. So async await is a syntax sugar for promises. So that means that it's not an either or, it's and, right? So promises and async, because async uses promises under the hood. So here you can say I'm defining a function called, a function called main. It is an async arrow function, right? So the other way to write this would be async function main. That would be the other way to write this. That's totally valid. And you'll notice that if I call main, I get a promise. Any async function call returns a promise. So if I did main.then, that works, right? Because main returns the promise, and you can run .then on promises. So you can mix and match asyncs and .thens. But you'll notice that inside of this async function, I can await instead of doing a .then. So I can await stat, or I can do const data equals await read data. So again here, and then if it includes return, await append file, and then console log. Right? But you'll notice that if I try to do that inside of a normal function, like let's say that I do main without async, get random time promise, you'll notice that it says await is only valid in an async function. So I'd have to change the function to say async in order to use await. So you'll notice that this makes it even smaller. We're even able to do like much more flat than even using a .then by using async functions, and that can make really complex promises more readable. So that's the talk. Franklin, like I said, is a fantastic dude. He's a mentor here. He may be sleeping right now because he was up pretty late last night helping other students. But yeah, so that's the end of the talk. I know we ran through this a lot quicker than I thought we were going to, admittedly. So please feel free to ask questions. Let me know what I can do to help. I'm available offline. Yeah. How can people contact me in Franklin? So Franklin, let me see if I can, hang on. I'm going to pull this up off stream. If I send the message to the StreamYard we're using, can you send it off to the chat? So Franklin can be found on LinkedIn. I can also be found on LinkedIn, although admittedly I am much more I'm willing to connect on LinkedIn, but I am also much more available on Twitter. So I am Crutchcorn on Twitter. Corbin says, "Oh, hey, Corbin." That's funny. So yeah, I am here. Actually, you know what I'll do? I'll put them on screen. Haha! I have the power to do that. Here, we'll do new screen, and I can just put all these links here. That's not hard to read. That's also hard to read for different reasons. By the way, if there's anything you want me to talk about, just because we have so much time, if you want me to talk about anything in particular that I may not have mentioned in the talk, please feel free to ask questions, especially if it's web stuff in general, because I pretend to know things about web stuff. Crutchcorn. I'm also available on crutchcorn.dev. So that is a blog that I help run. I say help run, but I started it. And it's called Unicorn Utterances. We actively welcome people to join our Discord. If anyone is looking for like pair programming or anything like that after the hackathon. Yeah, we have a Discord. We write articles that introduce concepts like how the browser parses HTML and DOM content in order to understand what it's actually doing, so on and so forth. So please feel free to join us there as well. So yeah. A few seconds ago, can I go over that since there's time? Yeah, sure. It'll be a bit more ad hoc. It'll be a little less structured, but yeah, we can totally do that. Although admittedly, I wrote this talk in a week, so maybe the talk was a little ad hoc too. So Actually, you know what? Let's not start with this. And the reason why we're not going to start with this is that I want to explain a concept that I explained better in another article. So this article explains what in how your computer speaks, right? So computers are really bad at natural linguistics, right? So whether it's English, French, German, like any language that humans speak, computers are really, really, really bad at understanding. And that's why code is not like English, right? There's like a lot of linguistical challenges. Like I even touch on this, like buffalo, 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 buffalo is a valid English sentence for very complicated grammar reasons. And a computer can't understand the context there. And it's even confusing for our context, right? So source code helps explain why things are, but the way that source code is computed is something called Lexing and Parsing and the abstract syntax tree, AST. So given JavaScript like this, const magic number equals 180 what, or 185, the lexer takes these strings and converts them into tokens. These tokens can either be one character, which is like the equal sign, or it can be multiple different characters. And these don't really have context. You can think of these like words, right? Words individually can be I, can be a, can be hello, but they don't form context together. So I can say, hey, hey, there, up, left, right, down. And that's a bunch of words together, but that's not a coherent sentence. Likewise, you can have a bunch of tokens together, like equals equals, that doesn't make sense contextually, but you can still tokenize that data as recognized symbols. So this is a const keyword, this is an identifier, this is an assign operator, this is an integer, so on and so forth. And what your computer does is it takes this code and it turns it into contextual parse data, right? So the parser takes lexer data, so tokens, and it turns it into more of like a sentence, right? So you have a constant. The constant declares something. That declaration has an ID, right? That ID is magic number, and the initial value is 185, right? So the computer is able to take this JSON data, which looks like this. So here we have a variable declaration. It is of kind const. That declaration has the decorator or declarator, which is the identifier, and the initial value, which is the numerical literal. And it can take this JSON and it can go, oh, I understand what you're trying to do. And it can turn it back into assembly code. Or Node.js is not directly assembly code, but it has machine code at some point. And the machine code can actually take your code and operate it the way that it needs to, right? So this is very similar for how compilers work. Compilers have to understand an AST, right, to be able to parse into other machine instructions, but even things like Node use an AST, right? So while that may not be obvious at first glance, the DOM, or AKA your HTML, does the same thing, right? So given a structure like this, right, we have like this formatting, just this spacing is just optional. It's not required. But the idea is that you have a parent, which is main. That parent has children. That child has children. So that UL child has a sibling, right? So they form relationships with each other, right? So it'll turn into something like this. This main has two children. These are siblings, you know, so on and so forth. And the browser takes that code and it understands how to, like now that it's a tree, the browser has a traversal pattern like you would any other tree, and be able to go from top to bottom. And it'll, like, let's say that our CSS looks something like this, right? IDB, the child of IDB, LI should be background red. So the first thing the browser does is it looks for IDB. Oh, that's not it, but that's IDB. Now we know that we can mark all of the children with that CSS for background red, right? So the CSS is able to take this DOM tree and manipulate it to be able to listen for what you're trying to do. This is why the correct tags matter so much. So like this is a pretty poor example, right? We're using like 5 divs. We have 1 parent div and 3 divs, but this doesn't tell the browser any information about what we're trying to do, right? Meanwhile, something like this, an ordered list with list items, tells the browser, oh, okay, we're trying to be a list, and we have a list item, and so on and so forth. And the reason why this is so important is for a few different reasons. One, it allows you to be able to do things like screen readers, right? So there are users who want to use your website that may have vision impairments or motor impairments that are helped by being able to understand what is going on the browser. So Windows is a little hard to turn on. I don't have it set up right now. I have it more set up on my Mac, but I could turn on a screen reader, which is shipped with like every computer, every phone, everything. And what it'll allow me to do is it'll allow me to read this as a list without any extra coding. Because I've told the browser that this is a list, it can actually read it as a list properly. Meanwhile, this will just read bananas, apples, oranges. It won't pause between them. It won't tell you how many items there are. It won't tell you what it is. It will just read the 3 words as if you type them in anywhere, right? The other thing that this does is it helps SEO. So if you're trying to get your website to show up on Google much more predominantly, this is super important because this is not a list of items to Google, because Google can't know that it's a list of items because you didn't tell your browser that it was a list of items. This, on the other hand, Google can, like, let's say that I had something like this, right? It's like not only did I have an OL, but I had, hang on. Let's see if I can, I'm not going to bother. So let's say that I had something like this instead. Right? So I had H1 foods that are healthy, right? And I had ID, title, and I had ARIA described by title, right? So what I'm saying here is that this list is described by this title with this ID, right? And now if Google's bot is going through my website, it can read this source code and go, oh, this is describing foods that are healthy. And now if I Google foods that are healthy, it may potentially select my website and give me what's called like featured snippets to explain what like foods are healthy if you ask like Google Home or something like that. So using the proper HTML tags is extremely important for SEO. It's extremely important for accessibility and very similar. So likewise, we can use JavaScript because we have the browser understands the tree of the elements. We can take that tree and we can manipulate it using JavaScript. This is how jQuery works. This is how React works. This is how Angular works. This is how everything works that interacts with the browser DOM. So let's say that we have something that has ID testing or main text, right? And we want to be able to get that element. We can then see what the inner HTML looks like. We can see how many children it has. We can see how many items have a certain class on them. And we can even do things like see what the height and width are. So like, check this out. Let's... hang on, there's way too much on my screen right now. So given this element, right? So this code sample, let's add an ID. So let's do ID equals code sample. And now we do document.query selector code sample. You can see that it highlights the elements in particular. So we can do get bounding box, and you can see that its height and its width are 110 pixels by 376 pixels. And that's not like predetermined. You'll notice that my CSS doesn't say any of that. It just is, right? The browser knows what height and width it is because it needs to be able to draw that on screen, which is super useful. But we can also change that. So let's say that we did .children, or remove children, and we'll do, actually, I'll set this to a variable. We'll do L equals that, L.remove child, L.children 0, And you'll notice that it disappears, right? Because the first child was the only child and we made it remove, but that element is still there. It just doesn't have any children anymore, right? So you can manipulate your browser using JavaScript because your JavaScript has access to the tree that your browser has to parse in order to understand like everything that it needs to draw on the screen. So that's how HTML is able to go from source code to actually drawing things on screen, and how tags in particular can be very helpful. So yeah, great question, Ryan. Thanks for encouraging this. So yeah. We have 10 minutes left. Any other questions? Because that's like the rest of this article kind of just goes into like more like specific examples, but doesn't necessarily. Jenny says hi, Corbin. Hello, Jenny. Yeah. Thank you guys for letting me talk about my weird dorky blog where I rant about random things. So if anyone has any like topics that they'd like to see me cover, in particular, what I'm going to try to do this year is I'm going to try to write not just an article, but a series explaining how to learn Angular, React, and Vue all at the same time. Because I really don't think that the differences between the three are so major that you couldn't learn all three at once. So I'm definitely going to be trying to take a stab at that, hopefully before the middle of this year, but time constraints allowing. But if there's any topics that people are like wanting to see more of, please let me know. I'd be happy to like write content on it. So yeah. Awesome. Well, I'm going to stop sharing my screen. Chris, feel free to shut it down. Yeah. So thank you all.